Hi, boys. Hope we're doing all right. As an extension to what we started today, there are a series of trigonometric truths. We generally call those identities that some far well known, others not so much. But the first family of trigonometric identities, and those are just substitutions or equations. One trigonometric expression is the same as another trigonometric expression. Happens to be called the Pythagorean identity. So let's derive those, or at least think of where they come from. Okay? And we'll go right back to the unit circle. And remember, the way that we get sine and cosine for any angle is we start resting peacefully at this initial point 1, 0, and we rotate, right? And that angle, which we can call x or theta, lands us at some terminal point, right? And we've been, at least we had in the winter, said, okay, the x value of that point is the cosine of the angle that got me there, and the y value of that angle is the sine of that angle that got me there, okay? So that said, a little different way of looking at that is, sometimes we have to create these reference triangles for which, the cosine is the same as the base of that triangle, the reference triangle, and the sine, the y value, is the same as the height of that reference triangle. It's the same thing, really. So that's how we get to that terminal point. Cosine, sine, we move over. Cosine, the base, we go up. Sine, the height, okay, of x, the angle. So just given that diagram, and given that the hypotenuse is in the unit circle 1, and will always be 1 no matter where you rotate it, it should be no surprise that the Pythagorean identity just applies the Pythagorean theorem, a squared plus b squared equals c squared, onto this particular triangle, or generalized triangle, reference triangle, within the 1 unit circle. And so, of course, when we square cosine, we get cosine squared plus the height of the triangle, which is sine squared, equals the hypotenuse squared, which is just 1. And that is the Pythagorean identity. So for any angle x, cosine squared of that angle plus sine squared of that angle equals 1. Right? And that comes directly from this reference triangle within the unit circle, the cosine sine definition, really, within the unit circle. Okay? Now we can write that if cosine squared plus sine squared equals 1. Sometimes you can say, okay, if you subtract sine squared from both sides, that makes cosine squared equal to 1 minus sine squared. It's the same thing. Or if we start with the original cosine squared plus sine squared equals 1 and subtract cosine squared, we can isolate the sine squared. Okay? So these are all equivalent expressions, equations really, both of which really come from the original Pythagorean identity. Cosine squared, the blue, plus sine squared, the orange, equals the hypotenuse squared 1. Okay? So this is one of several Pythagorean identities. The others we can also derive from that. Now, if we take cosine squared plus sine squared equals 1, and let's say I divide everything by cosine squared. Everything. And of course, when I say cosine squared, what I really should say is cosine squared of x, the angle. Now, what I get when I do that is, well, cosine squared x over cosine squared x, that's 1, plus sine squared over cosine squared. Well, sine over cosine is tangent. So sine squared over cosine squared is going to be, yeah, that's right, tangent squared. Equals, and then 1 over cosine is secant, if you recall. So 1 over cosine squared is going to be secant squared. And that's another version of the original Pythagorean identity. 1 plus tangent squared of an angle equals secant squared of that same angle. Okay? There's one more, in fact. Look. And again, I'm going to take the original cosine squared x plus sine squared x equals 1, which comes just directly from that unit circle that we started with. Definition of the sine and cosine. And instead of dividing everything by cosine squared, now I'm going to divide both sides by sine squared of x. Okay, we'll see what comes out in the wash. And what we get is, well, cosine squared over sine squared. Well, cosine over sine, that's cotangent. So cosine squared over sine squared, that's going to be cotangent squared. Plus, now sine squared x over sine squared x, well, that's just 1. And on the right, 1 over sine, that's secant. So 1 over sine squared of x is cosecant squared of x. And that is our third version of the original. Same, just we're dividing through by sine squared. Same as the original Pythagorean identity. Okay? So if you want to put these in your notes, there are 3 identities, and we can manipulate each one. But the first is cosine squared plus sine squared equals 1. That's the original P. Diddy Pythagorean identity. Comes directly from that unit circle right triangle, reference right triangle. And we can, like we did earlier, I did earlier, you can isolate either cosine squared or sine squared within that. We divide that by cosine squared, we get the second Pythagorean identity, 1 plus tangent squared equals secant squared. And if we divided that original by sine squared, both sides, we get cotangent squared plus 1 equals cosecant squared. Okay? So these right here, those are some nice substitutions that we can use whenever we want. And so let's indeed look at a case where we would or might use one or perhaps more of those substitutions. So look at this little nugget here. Okay? This is one we started today, I believe. And we started by looking at, okay, let's replace everything with sines and cosines. But guess what? There's an easier way to do that. Okay? I'm going to try to verify this identity. And as we've been establishing, you have to show what's on the left is the same as what's on the right. So that's a little bit easier said than done. But basically, we try to work, simplify, play around with one side until it ends up being the same as what's on the other side. So let's take the harder side, which is what's on the left. Okay? Now, BK was saying today, let's distribute that tangent x. Well, let's do that. The question is, what's tangent times cotangent? Well, tangent is sine over cosine. Cotangent is cosine over sine. One way of looking at it. Or cotangent is just 1 over tangent, if you recall. So when I multiply tangent by 1 over tangent, I just get 1. Okay, tangent x times 1 over tangent x, that's just 1. When I multiply that tangent x by the other tangent x, distributing, I get tangent squared x. And now I'm saying, okay, well that's cool, but how on earth am I going to show that that's equal to secant squared of x? Ooh, well, guess what? Yep, you guessed it. Watch. What is 1 plus tangent squared equal to? That's equal to secant squared by the Pythagorean identity, one of the 3 versions. So, I'm done. So all I have to do is go back to my proof, and by the Pythagorean identity, 1 plus tangent squared equals secant squared, which is, of course, what's on the other side. Okay? So I have a little algebra, and then from here to here, I have one of the Pythagorean identities. All right? 1 plus tangent squared is equal to secant squared of x. Okay? For now, you don't have to memorize those. You can just have those written on your page and use them when you need to. Okay? How about if we looked at, I don't know, let's try to find a fun one. How about this one? Ooh. Let's say we have to verify that identity. So I'm going to put a line there. I'm going to work from the left rather. Try to show it's the same as what's on the right-hand side. So you might remember that, okay, I can FOIL these 2 terms. So it's going to be first times first, that's 1. Now, I'm not going to write it because I know what it's going to be. It's, if you guys are following along, a plus b times a minus b. It's just going to be a squared minus b squared. But the outer and inner terms are going to cancel. Plus sine x, right? Those are our inner terms. Minus sine x, those are the outer terms. So those are going to cancel each other, sine x minus sine x. And then my last times last is going to be sine times sine. One's positive, one's negative, so it's going to be minus sine squared of x. Okay? So I just did a little algebraic expansion. If you recall, a plus b times a minus b, that might have been an easier way to do this. is a squared minus b squared. That's what I just did. Okay? Now, what I'm going to do is I'm going to jump over to the right side and just simplify that. 1 over secant. Well, remember, secant is 1 over cosine. So 1 over secant is 1 over cosine. So it's just cosine. So 1 over secant squared is just cosine squared. Okay? That's just a basic simple simplification. I get 1 over cosine squared. And so that just ends up being cosine squared of x. Okay? And now you're like, okay, how can I get that left side to be the same as the right side? Well, I don't know. Maybe it's got something to do with, that's right, the Pythagorean identities. So let's see if we can maximize this a little bit. So I'm going to go right back to these good old Pythagorean identities. And I know, okay, I know sine squared plus cosine squared equals 1. From that, I can figure out what either cosine squared is, just by messing around with this equation, adding or, subtracting sine squared or subtract cosine, or this, right? So what do I need? I need to know what 1 minus sine squared is. So if cosine squared plus sine squared equals 1, what's 1 minus sine squared? Well, I'm going to subtract sine squared from both sides. So on the right-hand side, I get 1 minus sine squared. And on the left, I just get cosine squared. Okay, so that's just another way of saying that original Pythagorean identity. So now I'm going to say, okay, 1 minus sine squared is cosine squared. I got that going for me, which is good. So I just have to replace by the Pythagorean identity the 1 minus sine squared with cosine squared. And of course, that ends up being the same cosine squared on the right. Okay? So this is a little tricky because I'm working both sides of this equation independently. Okay, I'm kind of working down on the left by itself, and then I did one little simplification on the right by itself. But ultimately, these guys match up at the end. What's on the right equals the left. I've shown that, and thus ends my verification of this other identity, part of which was using the Pythagorean identity, one version of it, from 1 minus sine squared to cosine squared. Okay. So what I want you to do is be able to, in our next class, come into class with these 3 Pythagorean identities in pink, now purple. We can manipulate each of those within that each individual identity, as we just did with cosine squared plus sine squared equals 1. Okay, and we're able to use those within the context of verifying other identities as I just did. Okay, so I hope you enjoyed this video. I'll see you guys in class. Bye-bye.